simple to use in C. This declares an array of integers with room for 5 values. Arrays are indexed with integer values. The first element is always number 0. This assigns a value 1 to the first element of the array. This declares an integer pointer and assigns the address of the array. Notice that you don't need to use the ampersand address of operator to assign an array's address. This is a special case in C syntax, and it's worth remembering because it's used frequently. The name of an array may be used as an address without the ampersand address of operator. This assigns the value 2 to the first element of the array. Because the pointer was assigned to the array, it is pointing to the first element. You can increment the pointer and it will point to the second element. In C, pointers are strongly typed, so they know the size of what they point at. So when you increment a pointer, it always increments by the size of the object it points to. So this assigns the value 3 to the second element of the array. This is another common technique in C. Here we're incrementing a pointer and using it at the same time. It's just a shortcut for the separate increment and assignment of the previous 2 statements. In C, a string is a special case of an array. To illustrate, let's look at an example. Let's make a copy of working.c, and I'll copy that and paste it into the working project and double-click to open it up. I'm going to start out by declaring an array of characters. And so we'll say character and S and just the 2 brackets. We're not going to put a number in for the size of the array because that can be inferred by its initialization. Here we're going to initialize it with a number of characters. S, a T, an R, I, you see where I'm going with this? An N, and a G. And then I'm going to give it a number 0 and a semicolon. And this is a C string. In C, a string is simply a special case of an array. It's an array of characters, and it's terminated by a 0 value. Some people call that a null terminator. So this null terminated array of characters is exactly the same as a string. In fact, I can do this. I can say string is and %s and give it the s variable, which is an array of characters that we've initialized right there, and give this all to printf, and it will print the word string. And I'm just going to save that and run it. It compiles it and runs it, and it says string is string. So this is exactly the same as if we had done this, which is, of course, the more common way to do that. So this simply initializes this character array with the letters string and the null byte, the 0 value. So this array is 7 characters long, and it holds the string string. And so if I run this, we get exactly the same result. In fact, we can treat this as a string. We can say for int I equals 0, while s sub I is not equal to 0, and then increment I. And we can just print out each character. %c will print a character, and we're going to say s sub I, which is actually of type character. And now when I save this and run it, see, we get all of the individual characters. There they are, str, in, and g. So we can see that a string is really just a special case of an array of characters. And a character pointer should index into that array just as we would expect. So we can actually do something like this. Instead of using the integer to index into the array, I can declare a character pointer like this, initialize it to point at the array. Remember, you don't need to use the address of operator with an array. And I can say while what is pointed at by CP, I don't even really need to compare it. I don't need to do not equal to 0 because I can actually use it as a logical value. This is very common in C. And increment the character pointer. And now instead of this s sub I can just do that. And so here I'm using this character pointer to index through this array. I'm using it like an iterator. And that's really a very, very common paradigm in C. So I save this and run it, and you see we get exactly the same result. There is our character string, string. So the combination of arrays and pointers is really powerful and really common in C. An array is a structure of variables of the same type, stored contiguously and indexed by an integer value. Because the array is guaranteed to be stored contiguously, it's also easy to iterate it with pointers, and C syntax lends itself well to this usage.